Hello guys, welcome to my channel. What you see before you here is a high voltage generator using an old black and white television flyback transformer. And you'll note that I have one capacitor on the top and I have the flyback on the right side, and I have this standoff here with this terminal. Now if you look very carefully, there's a very fine wire coming from the coil. It's so hard to see in this light, but you can actually do see it. It's right here, and it's soldered onto that, and that's acting as a post, so I can take my negative and my output from here. Now this output here can either be left as is, or it can be rectified going through a high voltage diode to give you a high voltage DC output, either positive or negative, whichever side you want to use. And that could be used as a reference ground. Now the underside, the outside of the box here, you basically have an LED that indicates power. This is a control from the timer circuit. This is another control for the timer circuit. One controls the bandwidth and the other side controls the frequency. On and off switch. On the back side of the box, you basically have an input. This is a plug that I made specifically for a connector that I have. You can either use AC or DC, it doesn't matter. The DC, there's no need for polarity because it's controlled on the inside with a bridge rectifier. A fuse, of course, and a fan. Now that fan is important because it has to remove the heat from the driver transistor for the coil. Now if you look underneath is basically, what you see here is you see the oscillator circuit using a 555 timer. That is the output transistor mounted on a heat sink. That's the on and off switch. The fuse is right here. The capacitor is down in here. And let me get another light here. You can see the capacitor there. And that is the bridge rectifier on the side, and down here you can see the LED. And so the circuit in here is actually very simple, and in the back here underneath this board there's a terminal strip that connects the driver coil from the transformer. Now what I did to the flyback is I wound this coil right here. It's only a few turns. Number 24, copper enameled, and that acts as your driver coil. It's only a single wound coil, it's not center tap, so that's driven by the 555 oscillator inside the box, and then you get an output. Now I'm going to show you this in action, but before I do that I want to show you the schematic for it. So let me put this aside for now and I'll show you the schematic. So here's the diagram. It's actually a very simple circuit. What you have is exactly what I showed you here. You have an input, a fuse, on and off switch, bridge rectifier, capacitor, the regulator, which is inside the box here, and you have the LED power indicator, a 12-volt fan. Now this fan here is actually physically very close to the output transistor here, because this transistor is mounted on a heat sink and you need to remove the heat away from this because it does get hot. That's your 555 circuit. This is the schematic for it. The first control controls frequency, and this controls the width, pulse duty. This is a pre-driver 2N3904. I'm using the 2N3055 output transistor. The diode is to remove spikes across the transistor from when the flyback is switching, and this is the flyback output transformer, and you get your high voltage output here. Now this here is ground, except that it's on a terminal strip, and you can either use this as a ground or connect it to ground, and you'll still get a high voltage output, but the reference to ground. If you don't want to reference this to ground, you can use that pin which you saw here. This is the actual pin I'm talking about right here, which is this point, and you could use this pin and this output together isolated from ground from this circuit. So that's a schematic for it, and it works very well. If I adjust these controls here, I can actually get this to produce a very quiet plasma output. So by changing a few components here, I can also adjust the frequency oscillation of the output so that I can get this into resonance. Right now, I would have to put these controls at some extreme limit in order to get the transformer into resonance, and I'm going to show you that. So that's the diagram right here. So let me bring the circuit back, or the unit back, and I'm just going to power it up, and I'm going to let you guys see what it does. So now the power I have coming in is from my power supply. It's right here. This is a plug that I made, and it connects to the back here, directly inside. Now the orientation doesn't matter. I can either go this way, or I can reverse the plug, and it's the same. It doesn't really matter, even though it's DC coming in, because the bridge rectifier, which is right here, will correct the polarity going to the capacitor. So it's irrelevant whether this is DC or AC, and if you use DC as I'm using, the polarity does not matter in each pin, okay? So that's why I designed it like that. Now, it's powered in, my power supply is on. I'm gonna switch this on, but before I do, I think I just got a shock there. But before I do, I'm gonna get something to poke this with, because I don't want to get electrocuted here. So just give me 1 sec. Okay, we're going to use this because it has a nice insulated handle. And let me turn this light off for now. And I'm going to turn this on. Now you're going to hear the fan going. That's the fan in the back pulling heat away from the heatsink. And you'll see a spark here. And then I'm going to adjust these controls to see if I can get a plasma going here. All right? So here we go. Oops, sorry about that. Okay, this is at a point now, there's no sound from the oscillation, and what I'm getting here is a plasma output, right? So you can see by adjusting these controls here, you can actually get the output here to create an in-resonance plasma. So I think it's a pretty good unit, and I use this for my projects that require some high voltage and just high voltages. For example, when I build very small lifters, and using balsa wood and things like that. You can download lifters from the internet to see what I'm talking about. And those are very light material, but they require high voltage. Now, this high voltage puts out roughly about between 30 to 40,000. And if you select the frequency correct, you can get much higher voltages. And if you reference this pin with this output, you can also get the spark to go much farther or get much bigger, all right, than what you saw. But anyways, that's the unit in action. And that's it. This is probably another project that you guys might be interested in building. If you are, you can either go back and look at the schematic that I showed you, or here's the diagram. And if you guys want to make it yourself, you can make it yourself. But what you need is you need to find an old black and white flyback transformer, as I've done. I actually picked up this transformer many, many years ago, and I always held it, so I finally found a use for it. But if you guys happen to have one, here's the circuit. You can also modify your your oscillator here. This is the way I built mine, but there's variations of many different variations that you can build your oscillator using a 555, or you can use other kind of oscillators using a 4011, 4049. There are many variations for this, but this is what I elected to use. So now, and of course the 7812 regulator is used because I'm constantly powering the 555 with 12 volts. The fan requires 12 volts, and the LED is wired to run off 12 volts using an 820 ohm resistor. So there you go. But the rest of the circuit, the variable voltage that you're using at the input here is applied directly to the transformer, and it's switched by this transistor, which is switched by the oscillator. So the voltage to the oscillator remains constant, but the voltage to the output stage is variable. It depends on what input you're put here. Okay, whether you use an AC transformer or a DC power supply, it doesn't matter. But anyways, here's the diagram. I hope you guys liked this video. Do not forget to subscribe, and until next time, enjoy your day, and we'll catch you guys on the next one. Thank you, guys. Bye-bye.